Welcome back. All right, let's take a look at some practice problems with properties of exponents. Now, these are much more involved than the problems that we saw in the first video. This is more the type of problem that you should expect to see on a test, all right? It kind of incorporates all the different rules all together. So where do we start, all right? The tricky thing about rules of exponents is that everyone can do the problem a different way and still arrive at the same answer. So there's no one right way to do any of these. But here's what I tend to do, all right? Focusing in on problem A here. I tend to try to get rid of zero exponents and negative exponents to start. That's usually where I go first. You don't have to do it that way, but you can. Or you could also go the route of getting rid of extra parentheses right away and trying to deal with that. Or you could try to get it down to just each variable showing only one time. So there's lots of different routes that I could take here. But the first thing I see is this c to the 0. And I know something to the 0 power is the same thing as 1. So that essentially just disappears because 1 times something else is the something else. So that's where I'm going to start. Next up, I'm going to take a look at distributing this exponent here. So I'm going to have negative 3 to the 3rd power. And then a to the 4th to the 3rd power, power to a power I multiply. And then c to the negative 2 to the 3rd is c to the negative 6th. All right, and then I can get rid of that extra set of parentheses over there because there's nothing to distribute. I can just make this 2b to the negative 8 and then a to the 7. Okay. Again, this is one path. This is not the only path to the answer. The next thing I'm going to do is simplify that negative 3 to the 3rd. Remember, that's negative 3 times negative 3 times negative 3. 3 negatives is still a negative. This is negative 27. And then I've got a to the 12th, c to the negative 6th, times 2, b to the negative 8th, a to the 7th. All right. I see I've got two a's here. So why don't I try to merge those together? This is a to the 12th times a to the 7th. I can add those exponents to get a to the 19th. In a similar fashion, I can take a look back here at the coefficients. And I can multiply those together. Negative 27 times 2 is negative 54. Okay, so coefficients just follow regular numerical rules. And now I've got these two remaining pieces, c to the negative 6th and b to the negative 8th. Now, the nice thing is I've got a coefficient, I've got an a, a b, and a c, not in that order, but I've got everything shows up just once. Now I just need to get rid of the fact that I have negative exponents. So I'm going to create a fraction. Anything with a negative exponent needs to move to the bottom of the fraction. So c to the 6th needs to go on the bottom. And b to the negative 8 becomes b to the 8th on the bottom. All right, so I've relocated both of those. The other two are going to stay up top. I'm going to keep the negative 54 because that's negative 54 to the positive first power. It doesn't have a negative exponent, so it doesn't move. Negative coefficients are fine and do not need to be relocated to make them positive. Negative 54 and positive 54, not the same number, okay? And then I'm going to have a to the 19th here. This is my final answer. Again, there are multiple ways that you could have gotten to this answer. You did not need to follow the same steps as me. If you choose to do it a different way and get to that answer, you're all set, all right? Let's take a look at problem B, which it probably is going to feel a little overwhelming when you first look at it. But again, you just want to focus on what's one thing I can do to start. And then once you do that, what's another thing you can do? Just focus on one rule at a time, okay? So what I notice here is, all right, I've got another y to the 0. Y to the 0 is 1. And 1 times 12, x to the 7th is just going to be 12x to the 7th, all right? So now I'm going to try to clean up the numerator first. So I'm going to write down that I have 12x to the 7th on the bottom. I'm going to distribute this exponent. The 2 out in front doesn't get changed. Let's see. X to the 3rd to the 4th power, power to a power, I multiply exponents. Y to the negative 2 to the 4, multiply those exponents to get negative 8. And the next that I've got negative 3, y, x to the negative 5th. Make my line a little bigger here. Okay. So I've gotten rid of all the parentheses up top by distributing in one exponent and then just dropping the other set. Now let's try to clean up as much as we can. All right, so where can we go from here? Where can we go? Where can we go? Let's see, I can combine these coefficients together. 2 times -3 is -6. And then I still have, actually, what can I combine together up top? Let's do some combining up top. I've got x to the 12th and x to the -5. Multiplying at the base level means I can add the exponents. So let's see, 12 plus -5 is 7. That works out nice. And then I can deal with the y's as well. Y to the -8 times y to the first. That's y to the first. -8 plus 1 is -7. And then in the denominator, I still have 12x to the 7th. All right, where can I go from here? It's an excellent question. Oh, here's something I notice. X to the 7th and x to the 7th, something divided by itself is 1. Those can completely cross off. Okay, and now I have -6 y to the -7 over 12. All right, now what can I do with that? I can say, well, -6 over 12, same as -1 over 2. And then I've got the y to the -7. Now the y to the -7 is my only thing keeping me from being finished here because I can't have a negative exponent. So I'm going to make this -1 over 2y to the 7th, which is a much simpler, much nicer looking expression than the original problem that we had back up there to start off with. Okay, so these are the types of properties of exponent problems that you should be prepared to deal with. All right, let me know if you have any questions on this.